All right, we'll go ahead and get started here and see if anyone else trickles in, but you might just hear me repeat myself. Thanks everyone for joining. This is day 3 of the seminar. If you missed day 1 and 2, they're going to be recorded, or they were recorded, and they will be sent out and on our YouTube channel probably sometime next week. So if you missed those 2 days, we kind of went through sizing for the most part in the beginning, battery sizing, inverter sizing, and then yesterday ended with a little bit of wiring techniques. Today we're going to be going it might be a bit of a shorter day. We'll see how long it takes, but we'll definitely have plenty of time for Q&A at the end. And we're looking to go through programming for the most part today. Q&A is open. So if you do need to, if you have any questions as the presentation goes on, feel free just to type them in the Q&A. We'll leave some time there at the end. Also, I will be doing polling again today. I think there's a few questions, at least one, and then a slide with a couple on them. So again, if you're having any issues with the polling, just write into the Q&A, and then I'll be sure to take a look as best as I can. Okay. Without further ado, let's jump right in. Okay, so we've gone through sizing, we've gone through a bit of design as far as inverter sizing, and even talked a little bit about AC coupling and retrofits as far as design goes. We ended with wiring, and now really I want to jump into programming, which is really a crucial point when it comes to setting up your SimpliPhi batteries. The programming is so key, as it adds the foundation of how the battery performs and ensures the protection is there that needs to be there to have a happy customer and no damage to the battery. Excuse me. Okay. So first we're going to jump into programming as it relates to charge controllers. So programming charge controllers. First and foremost, typically I would use 3-stage charging when it comes to a charge controller. I know sometimes that's a back and forth message. But really, when it comes to the charge controller, you're often charging from DC source, whether that's, a turbine, solar array, or maybe even a hydroelectric source. Most of those situations, you're harnessing a power that might not be constant, and we want to most likely use float in that case. So we will use bulk, absorb, and float, a 3-stage charging. And it's acceptable as if you're charging from PV, we want to make sure that we're harvesting all of that energy. I'll explain later why it might not be acceptable to use float in other situations, like something from the grid or an AC source. But for now, just know that you can use 3-stage charging when it comes to programming a charge controller with our batteries. Bulk and absorb, this is the bulk. As per the name, is where most of the charging happens. Bulk voltage when it comes to charge controllers, 28 volts DC for the 24-volt battery and 56 volts DC when it comes to the 48 volts. The absorb voltage is the same. I just want to preface this entire presentation today with that there are slight variations from inverters and charging manufacturers. And we're going to dive into the integration guides at the very end and talk about that. But just know that if you see something in the integration guide that's a little different than what you see here, then really that's okay. It's probably because the manufacturer has certain limits or steps that you can hit as far as programming goes. So don't worry too much about that. Also, this is the bulk and absorb, these are updated, so if you are using an older guide, I recommend always pulling off the website. If you're looking at our programming manuals, you'll find the most up-to-date, and always hard reset on your computer if you're not sure if you have the most up-to-date version. So again, the bulk voltage, I'm just going to assume that everyone that's on is kind of familiar with how charge controllers work, the 3-stage charge, bulk, absorb, float, for the most part. So as far as absorb time goes, this one's a bit tricky. We've kind of gone back and forth here. Absorb time right now for charge controllers, 6 minutes at 0.1 of an hour. 6 minutes or 0.1 of an hour, I should say. So sometimes it's asking you for an hour and you have to do 0.1, or sometimes it's asking for it in minutes. And you can do 6 minutes at that 56 volts. If you're using an older charge controller, sometimes the absorb time is not able to go very low to hit that 6 minutes or that 0.1. So you might look into using the alternative settings, 54.4, 27.2 for 24 volt, same thing for the absorb. And the difference here is that we're using a longer absorb time. So a lower voltage at 60 minutes or 1 hour. Again, some older charge controller models I've noticed tend to not be able, are not programmable down to that low absorb time. Even though we really don't require, most of the charge does happen in the bulk stage as it's climbing to that voltage. So for the most part, this longer absorb time is actually going to be a little less efficient at that lower voltage than using the higher voltage with the lower absorb time. Okay. Float voltage on the charge controller, 27.0 or 54.0, 24 versus 48 volt there. That's the float voltage that we recommend programming. Now, rebulk, recharge, depending on what it's called, I've seen it both ways, or even cycle volts, some other kind of funky names. Typically, I'll see it as rebulk or recharge. This is the setting that triggers a new charge cycle. We would typically set that actually at a range. You'll see it in our guide at a certain kind of set point, but really I want to explain today why you can actually use it you can actually use various voltage set points and why you would use one versus the other. So the range I would recommend is 50.2 volts to 52 volts. 52 volts is probably pretty high when it comes to a 3-stage charging situation. So I recommend probably not using that one with the charge controller for the most part, but unless you're going to use 2-stage charging. So why can you use different rebulks? Well, 50.2, 20% SOC, as we can see on the left here, that's 80% depth of discharge. So really, if you're using a solar array and it's a charge controller situation, you probably want to trigger a new cycle a little bit earlier than that. You might want it at 50% state of charge, 51.4. It's really up to the preference of the system, you know, how much PV is being harnessed. But if you're noticing that the battery is going into the night fairly dead and it didn't charge when it could have, that's where you up this rebulk recharge setting. So there is some manipulation. You can always follow the guide. I don't remember where it's set right now. I think 51 point something possibly, or maybe even lower than that. But you can always up this setting between those. Again, try not to use the highest end of things unless you're going 2-stage. But really, you could still get away with it. So what does CCCV mean? I've seen this a lot lately. It's going to start coming up a lot more on these charge controllers, and it's just a fancy way of saying constant current, constant voltage. We're talking bulk and absorb here. So constant current, we're talking, you know, we're pushing a certain amount of amps in the battery as the voltage climbs, and that's really where the majority of the charging tends to happen on the lithium battery. Constant voltage is when the voltage stays at, let's say if we set, to go back, we set our absorb volts at 56, then the constant voltage would be 56 as the amperage tapers off on the charger. So kind of tied together with this is you'll see something called end amps a lot. This is coming up a lot more. Really, this is a great setting. I would prefer this over time. If we can set the end amps, I always recommend setting the end amp setting. Basically what this does is end amp says what's the rating that how many amps do we want to see as it tapers off before we disconnect the charger. So we actually have a really easy calculation for this one. When you're setting end amps with our batteries, it's 2% of the battery bank's amp hour capacity. That's total amp hour capacity. So, for example, if you were setting end amps, and again, this is related to how the charger disconnects from that stage. 3 batteries, let's say we're using the 3.8 kilowatt hour at 48 volts. So we would do 75 amp hours is the total capacity of the battery in amp hours. We multiply that times 3 because there's 3 batteries in the system. We get 225 amp hours total battery bank capacity. Get 2% of that, 4.5 amps would be the end amps we would set. That means if it hits 4.5 amps at that CV stage, as it's tapering off the current, we would expect that the charger would stop at 4.5, even if the time limit has not been hit. That's 6 minutes, or if you're using an older model, it might be, the 1 hour rate. So really helpful setting. Can give you some really nice charging capabilities and a really smooth charging. You're going to have a happy customer if you use that setting. It's going to really prolong the life of the battery. Okay. Within charge controllers are great. They can limit the charge very well. You can have a big old PV array on a system that the battery can't handle, but you can limit it through the charge controller and really allow yourself to program what you want the max charge current to be. I'm going to just go ahead and answer this one question that just came up because I think it's important. Is the end amps the same as return amps? I believe so. Let me double check that for you, but I think I have seen it labeled as return amps as well. But same setting, I believe. Okay, so to my point, we can limit the charge of a charge controller. What's coming out of that charge controller and amps in hopes of making sure we're following the limits. We've talked a lot about C over 2. This is where it really plays a big part with charging. So this handy dandy chart here, I think we've seen in some of the other slides as well. Again, continuous and surge ratings for the battery. This relates to both discharge and charge in this case, as far as the continuous rate goes. Don't really worry about surge too much when it comes to charge. I really can't think of too many situations where that would make a lot of sense. The continuous rate definitely does. So if we were to set our current limit in the charge controller as we were programming, we would look at how many batteries we have. Let's say for this example, we have a single battery, a 2.9 kilowatt hour, 48 volt SimpliPhi battery. We would take the max current that's acceptable in that battery. We can just use the chart right here. We have one battery. It's the 2.9 model, 28.5. That is our max continuous charge rate because it's acceptable current. So we just do that times 1 since there's only a single battery in this case. And 28.5 would be our value that we would be looking for in amps DC for our current limit. If it's a charge controller, it's either going to be in DC or it's going to be in percentage. Percentage would just be basically the total charging ability of the controller and use that as a percentage. So if it's a 100 amp charge controller, that would be 28.5% instead. So I have seen it given in percentage, but most of the time I notice that it's in amps DC. So for our first polling question today, really one of our only other than the very end, is let's talk really here about current limit again. And in this example, let's assume we have 3 of the 2.9 kilowatt hour 48 volt batteries. This one should be a walk in the park, no problems whatsoever. But let's just go ahead. And again, we have some really great resources, and I'll explain a little bit more later after this question is done. Oh, sorry, ignore me there. That was the wrong poll. All right, there we go. That's the right poll now. Okay, so launched, and just go ahead and give me the answer of what those 3 batteries should be set for as far as max charge current. Give it a couple seconds here. Maybe we'll give it 30 seconds. See how that goes. Okay, we're going to go ahead and close the poll here. I see a few people. A lot of people haven't voted yet, but we'll end it anyway. Okay. So interesting results. We'll explain why. 6% said 60.5, 91% said 85.5, 2% said 90, and we had 2% or one person at 100.4. Okay, this one's super easy. As I mentioned, we have great resources. Why are they important? I just did the math for you on this page here. So we can see here, I mean, we can always do the math, 28.5 amps per battery times 3 to give us 85.5 amps DC as our max charger current limit. But if you just go to 3 here, we can see 3 batteries at 48 volts equals 85.5 amps DC. We gave it to you in this chart. Super easy, super helpful when it comes to programming. Save you a lot of time when it comes to trying to do math on site, anything like that. This chart will save you a ton of time. Okay, let's move on. Okay, so now let's go into inverter programming. And when I'm talking about inverter, I do want to just say I'm talking about inverter chargers. So, this inverter has the ability to charge from an AC source as well, and not just an inverter, but it does have that built-in charger. But again, we're talking about a DC source here. So this is a battery-based inverter. It is now accepting PV directly into it. This one does have an MPPT built into it, but again, that's the charge controller portion. So, okay, so with inverters, when we're AC charging, we really want to use two-stage charging. So we're only using bulk and absorb. We are not using that float voltage. We're not floating the battery, leaving it to sit there at that voltage as it just kind of tapers off. So bulk and absorb are actually a little different when it comes to the inverter charger programming. I would recommend 27.2 or 54.4 for 48 volt. And same thing for absorb at 60 minutes. You might have noticed that was the alternative set points that I gave for the charge controller. This is what I would always recommend using when it comes to the grid. Really is the most important one, as we can lessen the charge. We don't have to charge it really high, and we don't need to use up really fast charging in this case. We can kind of slow down the rate as we're not trying to utilize that PV production or whatever the renewable source is. Now this is very, very important. When AC coupled, always use the higher set points. I know that's kind of confusing because I just said when using the inverter charger, use the lower set points. But if you are AC coupled, meaning a PV array coming in to this system, AC coupled, definitely for retrofits especially, use the higher set points, the 28 or the 50 and the 56. Same thing for absorb at that lower absorb time of 6 minutes or 0.1 hour. Super crucial that you do this when it comes to AC coupling. This is something I'm kind of just toying with now and learning more and more about, but really it's going to help the frequency shifting occur at a much better rate, and you're going to get a lot better charge out of your battery without any, quick 5-minute charges. Okay, probably one of the most crucial set points on the inverter to be programmed. The battery management system does have a low battery cutout set, but it's very low, and it's too low, I would say, for sake of working through the system kind of as it should. So we require that you need to set the low battery cutout. That is the protection that we would want to rely on to disconnect if the battery drops too low. So you'll see here, this is an old chart, and I love keeping this here for this specific reason. It says 48 to 46 is 0% stated charge. That I would completely disagree with that. Going down to 46.0, if you look at our documentation, 48 is really where we call out 0. So with the old batteries, we kind of thought, maybe that was the range, and it probably was a little bit, but we've really refined our testing. 48.0 is considered 0% state of charge. So with your low battery cutout, you kind of have a range here. Let's just do it in 48 volt to 48.0, and we'll say that's 0% state of charge up to 50.2. You can always go higher if you really want, but that's 80% depth of discharge. That's typically the highest I'll see anybody set the low battery cutout. But the lowest you can set it is 48.0. The delay is present in most of these systems, so there is a delay. It's a short delay that basically says, you know, how long. I see a question here that says why. Can you clarify there? I don't know what you're talking about. Why? But I would love to get to it before we move on in case. Okay, I'll wait for that, but I'll keep going. So the delay occurs, basically it says, you know, wait this long before disconnecting, even if I see that voltage. If I hit 48, you know, wait, let's say 120 seconds. Now, if there's a higher load, like a C/3 or a C/2 load on the battery, then you need to make that a tighter window, so a less time as far as the delay goes. So like if you have a C/3 load and your low battery cutout set for 48.0, I would suggest setting your delay for 10 seconds. If you've got a really minimal load, you might be able to get away with 120 seconds. So it's really going to be a kind of, you can always leave it as default, but just know that if it is a heavy load and you're seeing a lot of tripping, it could be caused by that. And we can always look into that. Okay, never mind. Looks like we're all good on the AC coupling. Okay, so that question is done. Good point, Nancy. I just want to call this out too. Schneider has a max low battery cutout of 48.0. That is true. So some inverters do have that limit. 48.0 is acceptable. Now, does that automatically mean that you're always going to be discharging to 100%? Probably not. If the system's sized correctly, if the rebulk's set pretty high, and maybe even you have a generator trigger at 50.2, which we're going to talk about, you're okay. But yes, 48.0 is the lowest you can go, but it is still acceptable. Okay. As far as rebulk, recharge, very similar here, though I just want to, it's the same kind of leeway there, but I want to mention that if it's a DC coupled system, you want to set this lower than on the inverter than the charge controller. I would rather, if it doesn't know how to prioritize properly, we want to make sure that the charge controller is starting a new charge cycle and before the inverter is. If it's like a hybrid system, you don't want the grid charging if PV is available. Full disclosure, not always a problem. Some systems are very good at prioritizing what comes first. Okay, grid support or AGS values, that's automatic generator start. These are support functions where an AC source can help charge if nothing else is present. So if no PV is present and the grid support, you might be able to set that, like grid support's great to set at 50.2. You know, if you're, and then you can set your low battery cutout actually lower. So the hope is that the grid will take over. If no PV is present, charge. If the grid's not present, it might drop a little bit, but then it'll hit that low battery cutout. Gen support as well. I like it at 50.2. That makes a lot of sense to me that you turn on your generator at 50.2, but you can always have it. You can always have it wherever you want based on the SOC chart here. If the customer really wants their generator to turn on at 50% state of charge, set it for 51. But there is a lot of leniency. We don't tell you exactly what to set there because there is a lot of leniency, but just understand that those are support functions to charge from AC sources when there's no DC present, such as solar. Or even if it was an AC coupled system, it could still charge from the grid when there is no PV. Okay, cell voltage. This one's been a bit of a nuisance lately. So some, not all inverters, but some battery-based inverters do allow you to set the voltage in which the battery sells at. Some don't do that. Some just sell off, and that's just how it is. And you can't set the voltage. You can set the max amps to sell. But if it does allow you to set the voltage that you want to sell, this is related to what is the voltage that you want to sell down to or above, basically, think. So 52.8 volt DC is really where I see this to be the best function. I'm talking 48 volts. Most grid interactive inverters are 48 volts. I think there's a couple that are 24, but for the most part, if you're selling back to the grid, you're looking at 48 volt batteries. 52.8, what this really will allow is that it only sells off excess PV. The battery is nice and charged at 100%. This setting works really well when you type in 52.8 to make sure the customer is not selling their battery and basically discharging unnecessarily. Now, you can always sell a portion of the battery by setting this a little bit lower. Again, go back to that SOC chart. We can sell off a portion of the battery if the customer wants, but I've found that for the most part, the customer only wants to sell the PV excess. So 52.8, I'm thinking Outback, that's one that I know for surely does this. 52.8 is a great set point to make sure that the PV only sells. Okay, we flew through today. So we'll spend a little time on the website here in a second, but I just had these 3 questions related to what we just went over. We're going to do them one at a time here. So I'm going to go ahead and open the polls. Just know the first question is, what is the correct bulk voltage when using a newer charge controller? So I will go ahead and open the polls. Okay, I have to relaunch this one because I already accidentally clicked on it there, but now it should be open, and go for it. I'll give everyone about a minute-ish. All right, no math on that one. I'm going to give it 2 seconds here. Okay, we're closing the polls. All right, interesting. And then this is where it's, the settings change a lot, so it's always important to kind of keep up on it. What is the correct bulk voltage when using a newer charge controller? So we actually recommend 56.0, as I said. That's the correct voltage when it comes to the charge controller. If it was an older model, you could get away with the 54.4, depending on the absorb time. But it looks like there was a bit of a split there. Okay. So on to the next question. What is the correct float voltage when using a charge controller? Let me go ahead and open the polls again and give it about another minute. All right, let's close up here. Results are in, pretty split actually. 54.0 is the answer. That's what we're looking for. That is the only acceptable float voltage. There's no variation there. Okay, and the very last question, before we move on to a bit of monitoring and then programming that kind of situation, we were going to do is, what is the lowest acceptable low battery cutout voltage for a SimpliPhi 48 volt battery? Okay, hold on 1 second here. Let me pull up in the very last poll. and we will launch. Okay, about a minute here. All right, 5 more seconds here, and then I'll close up. Okay. Again, a little variation. It's okay. You know, I remember all of these settings. I work with them on a day-to-day basis. You know, this is why we have integration guides, and this is why they're so important and such a value to the customer, or to the installer, as a resource to not have to memorize these kind of things. So we'll talk about that in a little bit, but the correct answer in this case was 48.0. So again, 48.0 being the correct answer. All right, let's move on and let's wrap up our 3-day seminar here. Battery monitoring. Okay, so lithium batteries and battery monitoring is not my favorite topic. It is not the easiest thing to get done, and oftentimes is not the most accurate thing when it comes to monitoring lithium batteries. It's going to depend a lot on what kind of monitor you're using. Shunt-based monitor is really the most accurate. You know, reading the amps in and out, understanding exactly what's happening with the battery on a more physical level is where I would recommend. So this is definitely going to be typically more accurate than an SOC-based reading, and what I mean by that is maybe an algorithm that's programmed in to read digitally, and we'll talk about that too. Set points and how to program these monitors. Depending on the monitor, we probably have it in the integration guide. Like the Schneider monitor, we have a nice big section of exactly how to program that. We can dive into there when we hop on the website here in a little bit. Expected calibration time. This is something you really need to relay to your customers, you know, is if you're even using a shunt-based monitor, not even just a digital monitor, it's going to take a little bit to calibrate. It's not going to be accurate the first time, the second charge, the third charge probably. Let it calibrate because it's going to take a little while. Okay, as far as my recommendation goes, I just have to plug one that I like the most because it works the best with lithium batteries from what I've seen. That's the Victron models, the BMV700. I think they've got one more that's maybe has some Wi-Fi capabilities. So Victron, if you're on, love your monitor. It really is one of my favorite when it comes to lithium batteries. There's a lot of monitors that are out there that are not designed for lithium batteries. They're designed for lead acid batteries, and they don't work super accurately. So if you're looking to get a customer, you know, a customer that's really, you know, adamant about seeing that the battery has the correct capacity or anything like that, this is probably the only way to go to make sure that that is ensured, is the shunt-based BMV700, and be sure to use, you know, this monitor really has the ability to very accurately read, from what I've seen, a battery state of charge, voltage, and even capacity. Okay. As far as SOC-based monitoring and digital variations, this could mean a few different things. This could be voltage, the voltage meter versus the digital screen. This might be on the, let's say, the Schneider SCP here. You know, the voltmeter inside of the unit is probably a lot more accurate and tends to have a little bit of variation than what the actual screen is showing. I've just noticed there's a lot of variation between battery voltage and what these screens are showing. That does not affect your set points. For the most part, I've not seen that you know, it's a voltage-based set point. It's not going to be affected from what you're digitally reading. The set points still are going to work the way they should. SOC-based readings, I don't like. They don't work very well for lithium batteries from what I've seen. You know, this could be an algorithm where they're calculating out various things to see exactly how the battery is performing. They don't work very well. And even if you're reading off an SOC meter on the Mate 3, on the Schneider SCP, on the inverter's control panel, it's probably not very accurate. And you can definitely expect that those ones are going to take weeks sometimes to calibrate from what I've seen. With our batteries, they take about a couple weeks, maybe even 3 weeks. So if you're reading off something like the FlexNet DC or something, just make sure the customer gives it some time before they jump the gun, because really SOC-based readings are not super accurate, and it would take a little time for that to happen. A little side note for monitoring, web-based monitoring, it's a great platform, but I just want everybody to know that when you are AC coupled and you are monitoring the system, it's not going to look correct and that's a lot to kind of think about, but it's basically you've wired in loads and the solar array into the same AC, in or out, typically the out. That means that the wire or the reading of the PV in versus the load out is not going to show up typically correct on those web-based monitorings. So just understand that if you are AC coupled, it might not show exactly what you think it's supposed to be showing. That's just something I've kind of picked up on that I just wanted to share with everybody. Okay, so let's hop right in here. Resources for support. First and foremost, always give us a call, technical support. Tech support at SimpliPhiPower.com. We're always happy to help. And you can always call our main line, 805-640-6700, prompt number 2. That'll get you over to our support line. Somebody will snag the phone and help you out through whatever's going on. Monday through Friday, we are not open on the weekends, but always feel free to shoot us an email whenever. You never know, you might even get a response back on the weekend. Probably from me. Okay, let's go into product documentation. I think this is really crucial. I'm going to ignore spec sheets, warranties, installation, operation manuals for the time being. What I really wanted to jump in and show you related to today's presentation is a programming guide. So if we go to, let's say, the Outback guide, we have all this good information here, you know, related to the products, our typical sizing guidelines, some various kind of just guidelines to follow. I would definitely, on your own time, read through all of these things. They're very helpful, and they really show exactly what the limits of the battery are and ensure that you have a successful install without damage. That being said, the most important part of these guides, here's the set points that we talked about. And you might even see, so it might have some variations from what I mentioned, but again, that is related typically to the unit. So each unit's a little different, each can program a little differently, each interacts a little differently with the system. So these are great resources just to give you those settings, exactly what that specific model calls for as far as programming goes. Again, Schneider, you know, same kind of thing here. This one looks a little different in color, but there you go. There's showing the low battery cutouts different because it is the Schneider. We talked a little bit about that. It even goes from inverter into charge controller and really helps you program these kind of complicated pieces of equipment, specifically with our settings. And if there is any variation in that, you can see there that we kind of call it out. I mentioned the battery monitor. Look how many settings actually have to go into that battery monitor to make it even kind of accurate. So again, use these guides. They're very helpful. I will say, you know, pulling up here, we have 1, 2, 3, 4, 5, 6, 7, 8, 9 of these guides. If you see an inverter on there, or don't see an inverter on there, I should say, that you're really looking to use, just shoot us an email, the tech support email, or give us a call. We can look into it. These are just the main integrations that we've used. It's not meaning that these are the only ones we pair with. It just means that these are the ones we've tried and trued, and we know work, and we've at least had enough customers use them to build up an integration guide for us. Okay. So again, I'll leave this up for a second as I start answering questions, then I'll go to the final page here that we can see my email as well. But I really appreciate everyone hopping on today. I'm going to go ahead and open up the Q&A, and we're going to run through these questions, and then we'll be able to wrap up here. How do I become a certified installer? So to become SimpliPhi certified is not a requirement to install our batteries, but it's a huge benefit. You get to land on the where to buy page as a trusted installer. It does require 2 installations and the completion of a test that I administer. There's an application actually. Let me do this one more time here. Apologies. Let's go, whoops. Okay. Let's click on this link one more time. If you are looking to become SimpliPhi certified, you've already done some installs, you want to jump on that and be on this where to buy page map. And really it's not, again, we're not buying necessarily. It still shows our distributors, but it shows that you're an installer that we trust and we know that can install our batteries per our specifications. So go under support and SimpliPhi I.Q installer qualifications. And you will actually be able to pull up requirements here as well as fill out an application and submit that to us. So if you're interested in that program, just fill that out. Okay, back to the Q&A here. What does bulk and absorb mean? Again, these are just stages of charging. I don't want to dive too much into it. We could spend all day kind of talking about the mechanics of charge controllers, but I won't spend too much time there. Okay, good question. Those numbers seem low compared with version 3.4, the 3.4 kilowatt hour or the 3.5 kilowatt hour SimpliPhi battery, the older model stuff. What numbers should we use? I would actually always recommend using the most up-to-date numbers as far as, obviously with current, the batteries, the 3.4 and the 3.5 couldn't handle as much, so that's a different story. But as far as voltage set points, always use the newest voltage set point. Would it be correct to say that the lower voltage absorb is healthier for longevity of the battery? No, actually. So really it's, again, with PV charging, that 56 at the lower absorb time, it's still just as, and we're not finding that there's any extra stress on the battery. Okay, what exactly is happening during each of the 3 stages? 3 charging phases? Are there different voltages, currents, and times associated with each? I thought I covered that pretty well. I don't want to go into it too much again, but definitely reach out if you kind of want some crash course in charge controllers and those 3-stage charging. But again, CC, CV, and float. Think kind of in that sense. Constant current as it rises, constant voltage as it tapers, and a float voltage as it maintains. Can we get a link to the recording? Absolutely. Probably next week, though, we're going to put everything together and get it all out to everybody. I got confused with C/2, C/3, or C/3. If it is C/4, doesn't it mean I'm discharging slower, as it would take 4 hours to discharge the battery? Yep. So C/4, I'm just talking about, in this case, I was actually talking about charging. So a C/3 charge would be slower than a C/2 charge. How would I know if it's a C/3 load? Well, again, I think to go back to what we talked about the last couple of days, understanding the max charge of the battery. So we rate our batteries for C/2. Actually, let's just say, forget that. Let's just say we know the total amp hours is 75 amps. And what is 3-hour charge of 75 amps? That's as easy as it is. I'm not sure what this question means. It says, on a 48-volt reading, we are by 50% of SOC. I'm guessing you mean that you're showing 50% SOC when you're at 48 volts. Again, probably the SOC reading, just not very accurate. Voltage is key. Is the low battery cutout an open circuit condition? So an AGS closing with generator would have no impact. Well, the low battery cutout basically is opening the circuit if you want to think about it, between the output of the inverter. So charging sources, typically like a generator or a charge controller, still can charge while that circuit's open in hopes that we can get the battery charged up again without having to reset anything manually. Okay, Magnum 4048 with battery management kit includes SoC based on in and out power usage. So programming should be done on battery voltage rather than SoC as defined by the battery management kit, right? I have to look at the specific kit, but it's probably based, it's shunt based, so it's going to be off a lot more than just voltage. It's going to be off amps in, amps out, voltage, current rate, all sorts of different things. But we've actually got that in our Magnum guide. It goes over the BMK, I believe it's called. For the 10-year warranty on the battery, we aren't allowed to do below the 50.2 volts or 20% SoC, right? So the warranty's been updated a little bit. Check it out. It's actually more about throughput now than it is about the cutout. So again, 48.0 is really where you're going to want to sit as low as, but 50.2, if you drop below that every now and again, it's not going to do much difference to the battery. And really, I would say 80% is ideal for maximum life, but the warranty, as far as it's concerned, is more related to throughput now. And just making sure that you're within the limits of the low and the high. These figures are great. You are showing us is great, or these figures you are showing us are great, but some of my customers are still with older or new lead acid batteries. Are these figures going to work with other style batteries? I have no idea. I'm just related to the SimpliPhi Power battery in this case. I would say probably not. Definitely a good time to upgrade though, always, if you're going to try to switch over, and most of these older model equipment does work with our batteries. So if you're looking to have customers that want to switch out of lead acid, we can definitely make it work. Okay, Nancy asked about monitoring. Okay, the monitoring and how to prove the battery capacity. So again, really use one of the higher end stuff if you have a customer that really needs to see how much they're getting. I would again recommend that Victron. The Midnight Whiz Bang Junior. I don't know what the question is there, but yeah, I mean, that's probably okay too. It works. Here's a good suggestion for a battery monitoring. It's shunt based, lots of functionality, more. So it's the Bogart battery monitor. Never heard of it? Send it over though. I'm always happy to take a look. If they, support lithium batteries, it's probably a great monitor, and I'd love to check it out. So this is a question about the FlexNet DC and its accuracy. Again, even though it's shunt based, yeah, I see a lot of inaccuracy with it. So give it some time to calibrate. If you've already done that, we can peer through this caller tech support. We can peer through the settings and make sure everything's set up right, because that does sound like it's very off, not just kind of off. SoC, again, state of charge. Sorry if I didn't spell that out earlier. I think I was on the last couple days here. What is exactly what you need to calibrate? Not sure what that, I think that's just a little jumbled up there, but as far as calibration goes, once you program these kind of battery monitors, they typically calibrate themselves over a full charge and discharge multiple times. Is there a minimum number of 48-volt batteries needed for the Solarc to run efficiently? I hope you got to attend yesterday. We talked all about inverter sizing and minimum quantity of batteries. If you didn't, check out our resources. We've got tons of resources that talk about minimum quantity of batteries, battery calculation, making sure that you're following the CO2 guidelines, or even just wait for that recording and I will show you exactly how to size a battery properly for minimum. Do you have a presence in India? I'm not sure, actually. I would have to ask our sales team. But if you do have some inquiries, you can send it through our sales department, and they'll get you in touch if we do have a distribution partner in the area. What is the reason you do not recommend the SMA Sunny Island? Because the lithium battery setting the lithium battery settings require a connection between the battery monitor. So communication protocol, we don't have that currently with them. So we would have to rely on the lead acid settings, which is an SOC-based algorithm set point. So it's not just that it's reading, it might read inaccurately, but it might set off set points inaccurately and cause issues. Can you shed more light on inverters that take DC inputs directly from PV's PV array? As far as the battery-based stuff goes, typically it's just going to be needs to come in as AC source for the inverter charger. Charge controllers can take in DC direct, and they're the most efficient way to charge a battery by far. Or you could always use grid-tied inverters to invert at the array from DC. Could the SimpliPhi batteries be paralleled with another manufacturer of the same chemistry? Absolutely not. Sorry. That's going to be a no-go. What is the procedure to become a distributor of your products in West Africa? I think we have got a couple of distributors out there already, but just shoot us an email at our sales line, and just somebody will be in touch with you from business development to talk you through requirements. And if you don't fit those requirements, you can always look into buying from one of our distributors at certain levels. So thanks for the kind words. So question about why am I using 2-stage versus 3-stage? 2-stage on inverter, 3-stage on charge controllers, again, because it's just a waste of power really when we're charging from the grid or from most AC sources to use that 3-stage charging. We don't want to float off the grid or off a generator or things like that. Okay, awesome. So recording will be sent out again, just so everybody knows. I see a few questions again there. Recording will be sent out as well as on our YouTube page, probably sometime next week. Are these made on the USA? Yeah, we actually manufacture in California, in Oxnard. Is there a minimum charge for the batteries? Yeah, I mean, not technically. You're not going to hurt it by charging really low, but you're never going to get a full charge. I mean, there's definitely a threshold where you want to be pushing a certain amount of voltage and amps in. I don't really have that offhand, though. If you've got a scenario, though, where you need to trickle charge very low, just let us know. We can look into it. Thanks so much, everybody, for the kind words. Can the batteries only be supplied by a SimpliPhi distributor? For the most part, I think there's a few cases where that comes differently, but yeah, for the most part, through a distributor. If you've got a specific project you just want to talk to us about, you can always contact us. But I think almost all the time they'll get you in touch with the distributor for the purchasing. Okay, awesome. Well, looks like I did great on time here, so we got just a little bit. Please shoot me over an email. Sorry, here, I'm going to just pull this up. There you go. That's my email address, direct. Do not hesitate to shoot me any emails. I'm happy to answer questions or pass you along to the right people. But you can always also just reach out to our main line, and you'll almost always get somebody right away, no waiting. So don't hesitate to reach out to us. Again, I just want to really thank everybody for the 3-day seminar. This is something we're just kind of messing with now. The polling is new. I really liked it, and really, exciting to see everyone interact, and hoping that everyone learned something out of it. If there's any lingering questions, again, just shoot me an email, give us a call. Happy to help always. Thanks everyone so much, and I hope you guys have a great weekend.